So in the previous session we were saying about the conservation laws. How energy remains constant as a function of time, homogeneity in time, homogeneity in space, and isotropy in space. So these are the three conditions we have seen. So homogeneity in time gives you conservation of energy, homogeneity in space gives you conservation of momentum, and isotropy in space gives you conservation of angular momentum. So now we'll see the symmetry rules. So whenever you come across a physical quantity, you must look for this symmetry rules also. I mean, to confirm the validity of those physical quantities. Let's say you're dealing with forces or energy. Energy is not a vector, so forces, momentum, electric field, magnetic field, all these things, they obey these symmetry operations. So after certain set of operations, what is the final status of the vector? To confirm that, you must verify these symmetry operations. Whether the final result arrived is correct or not can be confirmed by verifying these symmetry operations. Okay, so the first symmetry rule is inversion. Inversion. So it is a spatial mirror image in all the three XYZ directions. So if you are given any vector, you take a mirror image in all the three XYZ directions and confirm if there is a sign change or not. Okay, for ordinary vectors, we call them as polar vectors, like force, acceleration, displacement, all these things. When you take a mirror image, vector sign changes. So let's say this is a vector. That could be anything, displacement or acceleration, force, could be any vector. This is a polar vector. So this will have fixed direction and fixed magnitude. So now I take a mirror image in all the three directions. So I have to keep a mirror along x-axis, along y-axis, and along z-axis. So if I take x-axis like this, so it's y and z, my mirror should be perpendicular to the axis. Okay, so if I am keeping mirror along x-axis means it should be perpendicular to that x-axis. So now what happens? In the mirror image looks like this. So if you keep the mirror head on to the vector, it will be flipped. Let's say this is a, this will be minus a because its direction changes. So now keep the mirror along y-axis. So this is my vector now. So I have to apply on the resultant vector. I have to apply the mirror operation on the resultant vector. So now I am keeping the mirror here. Okay, so now this is the image. No change. And then I have to keep mirror along z axis. So it should be, so here it is cross, like. So now the mirror should be along z direction. facing the board. So now the image will be in this direction. So final vector, so inversion operation on A gives you minus A. So this is what happens with normal vectors or polar vectors. So now we look for pseudo vectors. Pseudo vectors are usually the result of cross products. Okay, like an angular momentum, L is R cross P. So it is a result of a cross product. I mean that won't actually represent any movement along that direction. Let's say, I mean, if you are considering displacement, the direction of vector gives you the direction of motion. Even acceleration, force, everything, the direction of vector represents the direction of activity. Here, for pseudo vectors, direction of vector is actually perpendicular to the direction of activity. Okay, so these are called pseudo vectors. So now, let's say consider circular motion. How to bring an object into circular motion? Yes. So we have to apply two perpendicular forces on the object. Let's say the object is moving in this direction. Apply a force perpendicular to this. So if you pull it in this direction, what happens? It moves diagonal to this. It moves in this direction. Okay. Again apply a force perpendicular to this. It changes direction. So at every point, if you apply a perpendicular force to the direction of motion, the object comes into circular motion. Okay. So now, let's say the object is making 10 rotations per second. We have to represent that activity as a vector. Let's say the length of the vector 10 centimeters is representing 10 rotations per second. And if the rotational speed increases, let's say if it becomes 20 rotations per second, then I change the length of the vector to 20 centimeters. Okay, so now how to represent the direction of motion? So there are two possibilities. One is clockwise, another is anti-clockwise for circular motion. So now which way should I represent the direction of motion? I mean vector. Magnitude is okay, clear. Length of the vector represents the number of rotations. Length of the vector is proportional to number of rotations. So now, which way should I represent the direction of motion? At every point, the direction of motion is changing from point to point. Even if you consider a very narrow space, the direction of motion is changing continuously. So which way should I represent the vector for this activity? This way, this way, this way, this way. Tangent is this. I mean, this is the velocity, this is the force, centrifugal, centripetal force. This is the velocity vector. I mean, wherever on the circle, if you draw a tangent, you will get the instantaneous velocity. Vector direction. So now, where should I represent? I mean, the entire activity of circular motion, let's say clockwise or anti-clockwise circular motion, entire activity should be represented by a particular direction. Which direction should I take? Means the entire activity cannot be represented on the plane with a single vector, because activity itself occupies the entire plane. So in this case, the resultant vector direction is taken by, I mean, there are two possible rules. One is right hand thumb rule, another is left hand thumb rule. Most possible convention is right hand thumb rule. So if the direction of motion is represented by curl of your fingers, the direction of vector is along your thumb. So for anti-clockwise motion, so if the object moves in anti-clockwise direction, vector is represented perpendicular to that. So if it is clockwise, curl of fingers represents direction of motion, the thumb represents the direction of vector. So how to represent that mathematically? So we have to take cross product of R and P, and then we should get the direction of L perpendicular to the plane containing R and P. So we'll have two possibilities, right? So how to represent the radial vector? What is the direction of radial vector? In circular motion, let's say object is moving in a circle. Object is moving in a circle. So here P is the momentum. So at any point, if you draw a tangent, you will get the direction of velocity, and that is the direction of momentum multiplied with mass. So at this point, let's say this is the momentum vector, and this is the radial vector. Radial vectors connects the center to the object. It is directed from center to the object. So this is the direction of radial vector. So now we have to take the cross product of these two vectors, and resultant direction is perpendicular to the plane containing R and P. So which way? Is it upwards or downwards, or out of board or into the plane? Which way should we take? Perpendicular direction. Both are valid, right? So here the rule is we have to travel. I mean, here also right hand thumb rule applies. Curl of fingers represents the direction of motion from first vector to second vector. So let's say if you are taking R and P, you have to take the direction of motion from R to P. This way or this way? It's a matter of discussion that we'll see. And if your curl of fingers represents the direction of motion from first vector to second vector, then thumb represents the direction of vector. So which way should I take? This one, first one, or second one? Most possible option looks like this, smaller. Okay, but a smaller angle should be considered. But angle definition, angle must be defined between any two converging vectors or two diverging vectors only. Fundamental definition. Angle converging or two diverging vectors. So we have to define angle between either two converging vectors or two diverging vectors. Here one is a diverging vector, sorry, at this point one is converging vector, another is diverging vector. So first vector is converging, R is converging, P is diverging. So then we have to use the first rule of vectors. So vector keeps its magnitude and direction intact I mean, as long as you keep the magnitude and direction of vector, you can shift it anywhere. So that is what we use in addition of vectors, subtraction of vectors, all those rules. So as long as you keep the magnitude and direction of vector, vector properties will not change. So now I'll shift this vector. Let's say this is R, this is P. So I shift the vector forward so that I get a diverging pair. Okay, then take the angle, smallest angle between those two vectors. Then the direction of rotation is given by your curl of fingers, then thumb gives you the direction of vector. So L is obtained by, so if this is the direction of motion, this is the direction of vector. So other way also you can try, you can obtain converging pair by shifting P downwards. So this is the R and this is P. I shift P vector downwards. So now I got converging pair. So this is P, I shifted it downwards, converging pair. Now I have to travel from R to P. So that is also anti-clockwise. Then the direction of vector is perpendicular to out of plane. So it is out of plane. Okay. So if the object moves in anti-clockwise direction, vector will be above the plane. If the object moves in clockwise direction, vector will be below the plane. So that is right hand thumb rule. So if you take left hand thumb rule, vector direction changes. For clockwise it is upwards and for anti-clockwise it is downwards. So most possible conventions consider right hand thumb rule. I mean, if you start working on left hand thumb rule, you have to continue with that for the rest of your course. But most often people use the right hand thumb rule. So we continue with right hand thumb rule. Okay, so now I'm taking this inversion operation on pseudo vectors. So pseudo vector direction, I mean, there is no standard rule for that. Either you can take right hand thumb rule or left hand thumb rule. So it's your choice. So I'm choosing right hand thumb rule. So that is why they require a separate identification and separate rules. So if you apply inversion operation on that pseudo vector, what happens? So I'm taking anti-clockwise motion. So the vector is directed perpendicular upwards to the plane. So now I'm taking x direction mirror. So this is my x. So the mirror is perpendicular to x axis. This is x mirror. So here it is x mirror, y mirror and z mirror. So what happens? It looks like this. In the mirror, right? So then what is the direction of vector? Downwards. So it looks clockwise, so it shifts downwards. So you have to see only the object motion. Vector direction will be decided later. So you are not mirror imaging the vector, you are mirror imaging the object only. So vector direction will be decided later. Okay, so this is the vector. So now I take, so this is the vector and I am taking y mirror. Which way will it rotate? No change. So if you keep the mirror above the object, inside the mirror, it is still rotating in that direction. So the vector direction is the same. Now I take Z mirror. So mirror is facing the board. So this is the mirror. So which way will you see that? So if it is on the other end in the mirror, you will see it the far end. So mirror is facing the board. So this is the direction of vector. Ultimate direction is this. So inversion operation on a pseudo vector gives you same sign. Okay. So you have to decide the direction of vector after mirror imaging the object. Okay. So what is the conclusion? Ordinary polar vectors change sign upon inversion operation, whereas the pseudo vectors will not change sign, they remain same. So that is how you identify the direction of vector. I mean, this is most important observation in beta decay, Fermi theory of beta decay, that led to the discovery of a new particle called neutrino. Okay, because this inversion symmetry was not satisfied by those vectors, because I mean they're talking about some electron coming out of a nucleus. So that we will see at that time. So but this inversion operation confirmed the existence of a new particle in beta decay. So what is that beta decay? When a neutron into a proton plus an electron, proton plus a positron plus a neutrino. Otherwise, proton gives you a neutron plus an electron. Proton plus electron. Here it is neutron plus positron plus an antineutrino. Which one is correct? Okay, this is antineutron, this is neutrino. So somehow an additional particle needed by this conservation laws. Inversion symmetry was not satisfied with just two particles. So when one particle splitting into just two particles, these are all spin-off particles. Neutron is spin-off particle, proton is spin-off particle, electron is also spin-off particle. So when a spin-half particle is divided into two spin-off particles, net spin is 0 again. 0 or an integer. Here it is a half integer. So they needed an additional particle with spin half, so that the total spin is again a half spin. So that was one confirmation that an additional particle is needed to balance the equation. And another confirmation is inversion symmetry, that we will see at that time when we discuss about that beta decay. Okay, so this inversion operation confirmed the existence of a new particle in those nuclear reactions, and later it was discovered. So that is how these symmetry operations play a crucial role, especially in particle physics. Another symmetry operation is time reversal symmetry, Okay, so this is clear, right? Spatial inversion. So next one is T symmetry. This is also called time reversal symmetry. So if you reverse the time, what happens to an event? That means record an event as a function of time and play it backwards. So how the objects move is a matter of discussion now. And how the physical quantities change is a matter of discussion. So normally when you record a video and play it backwards, entire activity will move backwards. So if some person is moving forward, it will move backwards now. But in physics, how physical quantities vary their change, where there is sign change. Whether there is a sign change or not is a matter of discussion now. So we have to confirm it mathematically. Let's say you have velocity. Velocity is what? ds by t, displacement by time. Rate of change of displacement is velocity. So if you apply time reversal operation on this, okay, what happens? Wherever you have time here, so let's say v is a function of time. So if you apply time reversal operation on v, you have to change the sign of t. So this is v of minus t. Wherever you find t, you have to replace it with minus t. So this becomes ds by d of minus t, so which is minus ds by dt, which is minus v of t. Okay, so if the velocity is in this direction, if you apply time reversal operation, you get opposite vector. So that is about time reversal on velocity. What about acceleration? Acceleration is also a function of time. This is d square s by dt square. So if you apply time reversal operation on acceleration, so wherever you find t, you have to put a negative sign before that. So it is a d square s by d of minus t square, which is d square s by dt square. So acceleration will not change sign upon time reversal. If acceleration is in this direction, it remains same. Yeah, check sign will change because it is a third order derivative. Okay, so like that you have to see various physical quantities, how do they behave upon time reversal. So these are the two tests for confirmation of or conservation of those vectors. One is inversion, another is time reversal. So if there is a first order or odd number time dependency, odd number power of time dependency, then time reversal will give you negative sign. If there is a even number power of time dependency, then time reversal operation gives you same sign. So that you have to identify. And spatial inversion. For polar vectors, spatial inversion gives you negative sign, and for pseudo vectors, spatial inversion gives you positive sign. So these two are the confirmation tests for vectors. How do they keep their identity after any specific set of operations? Okay. So a set of physical quantities like displacement, parity is inversion symmetry, T is time reversal symmetry. So displacement, inversion negative, and T symmetry positive. Velocity, parity negative, T symmetry negative. Acceleration, parity negative, T symmetry positive. Angular momentum, parity positive, T symmetry negative, because this contains only one time factor. ml square t power minus 1 dimension formula for angular momentum. And torque, parity positive, T symmetry positive. Torque has dimensions of energy, ml square t power minus 2. So it is T symmetry positive. Energy is not a vector, so it is parity positive. T symmetry is also positive because double order in time. Curl gradient, they are not time dependent, so T symmetry positive, and they are results of some sort of cross products involved, curl. So parity positive. And electric field vectors, DEP, potential, magnetic current, all are parity negative. Electric field vectors are parity negative because the field or force directions are along the activities along the direction of vector. They are parity negatives. Electric field is directed along the direction of force. So they are parity negative, T symmetry positive. And magnetic field vectors, BHMA, and electric current, these are all parity negative and T symmetry also negative. Pointing vector, parity positive and T symmetry negative. And these physical quantities, permeability, permittivity, epsilon, epsilon naught, mu, mu naught, chi E, chi m, susceptibility, all these are parity positive and time reversal also positive. Electric conductivity, both parity positive and time reversal positive. Electric conductivity. Magnetic conductivity, it's both parity negative and time reversal negative. So these are the verifications, like wherever you deal with these vectors, you must confirm whether the resultant is obeying these conditions or not. Like time reversal and parity should be verified. Right, so coming to this direction of vectors, we have a basic conflict when we define the direction of electric field. Let's say all these force, displacement, velocity, all these are clear. I mean, the direction of vector is along the direction of the activity. right? So now coming to electric field, what is the direction of electric field? It is given by, let's say, Coulomb force between two charges is given by what? Q1 Q2 by R square. So there are two charges, Q1 Q2. R is the radial distance between them. So now the force is a vector. So which way should we mark this force? R is the radial distance, Q1, Q2 are the charges. So what is the direction of the force is a matter of discussion now here. And coming to electric field, what is electric field? It is the force experienced by unit positive charge. So we replace one of these charges with a unit charge. Another is Q. So then electric field is defined as force experienced by unit positive charge, Q by R square. Now what is the direction of this vector? This is also a vector. So how to define the direction? So let's say the force applied by first charge on second charge, F1, 2, 2. What is the direction of force? Both are, let's say both are positive charges. Both are positive charges, and I want to see the direction of force applied by first charge on 2, 1 on 2. What is the direction? It is directed from 1 to 2. That to positive charge. So since the charges are positive, so plus Q1 multiplied by plus Q2 by R square, and you have to keep so for that purpose I am keeping R cube and a vector R. So I am taking a magnitude R cube and the vector R. That is the radial vector connecting first particle to second particle. So this direction of vector is controlled by sign of the charges, and I mean direction of the force is controlled by sign of the charges. If both charges are positive, the force will be along the direction of radial vector from 1 to 2. So the force produced by charge Q1 is along that direction. What about Q2? F21. So this is F12. Force applied by charge 1 on 2. F21 is what? Force applied by charge 2 on 1. So what is its direction? It is directed from charge 2 to charge 1. It is in this direction. So this Q1 charge is pushing the charge Q2, and Q2 charge is pushing away the charge Q1. So both are pushing away each other, so they will move apart. So this is the direction of force. So this Q2 will move in this direction. This is the direction of force on Q1, so Q1 move in this direction. So what about if you have one positive charge and one negative charge? Q1, Q2. This is radial vector. So F12 is plus Q1 multiplied by minus Q2 by R cube radial vector. So it is along the line connecting 1 and 2 with a negative sign. So the force produced by 1 will be in this direction. This is F12. because you have a negative sign over the charge. Radial vector is always directed from the point to the object. Radial vector definition is that. Even in your circular motion you have defined that. Radial vector connects the point to the object. So here this radial vector connects Q1 to Q. It is directed from Q1 to Q2. And the negative sign is coming because of the sign of the charge. So ultimate result F12 is directed towards Q1. So it is a force produced by charge 1 on Q2. So Q1 start moving in this direction. So the same way F21 is what? Plus Q1 minus Q2 by RQ radial vector. So F21 is along the line opposite to that. So it is in this direction. So F21 is in this direction. So charge Q2 will pull the charge Q1 towards it. So Q1 move in this direction, and at the same time Q2 will move in this direction. So the radial vector is always from point 1 to point 2, from center to the object, from the point of observation to the object of under observation. So that is the direction of radial vector, and here the final sign of force is controlled by the sign of the charge. So coming to electric field, we have only one charge and one test positive charge. So the electric field direction is given by what? So E also can be written as Q by RQ followed by radial vector. So here the direction of vector is controlled by sign of the charge. If the charge is positive, radial vector is directed away from the object, away from the charge. So if the charge is negative, radial vector is towards the charge. So here sign is decided by the sign of the charge, or the direction is decided by sign of the charge. Radial vector is always pointed from the point of observation to the object. Okay. So rest of the things we will discuss in the next session.